Hi and welcome to E-ZTutoring. Today we're going to cover how you can simplify monomials. Now in these three different cases we will use three different exponent rules. Now you have exponent rules dealing with multiplication, division, and when you have an exponent on top of another exponent. Actually I was supposed to put a 2 here and I forgot. So anyway, starting off with the first case, having an exponent on an exponent, what do? Well, first, we have to realize that inside this parentheses is multiplication. 2 times z squared. Whenever you have multiplication and you have an exponent on all of these terms, you must distribute the exponent to every single term. This is a very, very common mistake that students will make, and students will generally distribute it only to the z. Another common mistake that I always see is this right here. If there is addition or subtraction, you are not allowed to distribute that exponent. You are only ever allowed to distribute the exponent when you have multiplication or division. All right, now that that's covered, we can go ahead and distribute this. So now we have 2 to the 5th, and z. Originally this was z squared and we distributed a 5. What do you do with the 2 and the 5? You multiply them to get 10. So whenever you have an exponent on an exponent, you must multiply them. All right, 2 to the 5th will give us 32, and then we have z to the 10th, and this will be your final answer. That is how you simplify an exponent on an exponent. So now how do we simplify this one? So we're multiplying these two terms together, so what we have to do is we first have to multiply the numbers together. We have a 2 and a 3. I always recommend doing the numbers first and then the variable. This is going to help you stay as organized as possible. 2 times 3 is easy. That gives us 6. And then b to the negative 3 times b to the 7. We put just one b, and now when you multiply them, you must add the exponents together. So we do negative 3 plus 7, which gives us 4. And that right there is finished. And that's your answer. So it's very, very important to remember these rules. Exponent on exponent, multiply. Multiplying two terms, you add the exponents. And division, I'm sure you guessed it, we subtract the exponents. So once again, let's do the numbers first and then we'll do the variables. 20 divided by negative 5 is simply negative 4. So we'll go ahead and put a negative 4. And then we have x cubed over x cubed. The same thing over the same thing. You can simply cross them out and it becomes just 1. So we don't have to worry about that anymore. And then y cubed over y to the 7, all you do is do 3 minus 7. 3 minus 7 gives you negative 4. So we get y to the negative 4. Another way you could have done is, you could have said that 20 over negative 5 gives you negative 4 on the top. And what you could have done is you could have said, out of these 7 y's, 3 of them will cancel with the ones up top, so you can cancel this and cancel 3 of them here and be left with 4, and just leave a y to the 4th on the bottom. So there's multiple ways to do these math problems, especially when it comes to division like this. The way I recommend it would be this way, just because it's more straightforward. It'll be the same way every time. All you do is subtract the exponents. And of course, you can then use the negative exponent rules to go from here to here. So that is how you approach this problem in those two different ways. You could choose which way you're more comfortable with. One more thing I'd like to talk about, another mistake that I see so much of the time is, say this were addition. So it's the exact same monomial we had up top, except with addition in between. And what students actually will do is they will cross out one term on the top and the bottom. You are not allowed to do this. You're only ever allowed to do this when it is multiplication or division. So that is how you simplify monomials using the 3 different exponent rules. If you guys ever want ACT or SCT help, be sure to visit my website, www.E-ZTutoring.com. Thank you guys, and have a good day.